Okay, the next section is solving limits analytically. The easiest way to do this, and remember when I said analytically, I meant algebraically, and these are the old school methods because we love them and they're super easy and you learned them last year. So now what I want to do is just show you quickly how to do direct substitution. This is sort of the easiest of them. And this is when you can just substitute in 5 for your x, and your limit here is -2. Here you'll sub in 5 for your x, you'll get 25 minus 15 plus 2 equals 12. And here, this is a constant function. Remember the constant function where you have this straight line, this is y equals pi. So anywhere on that whole function, including where x equals 5, this limit is going to be pi. Next, we have cancellation. This is really used a lot with rational functions. So what you want to do is factor the numerator. So I have x minus 3 times x plus 2, all divided by x minus 3. I cancel out the whole because, of course, a whole, like this example up here, a whole does not cause a limit to not exist. So we're still good with the whole. And now that I have just the x plus 2, I plug the 3 into the x plus 2, and I find the limit through direct substitution is now 5. So let's do factoring here, x plus 2 divided by x plus 2 times x minus 2, and then cancel the x plus 2's. Let's plug in a -2, and we're left with 1 over -2 minus 2, which is -4. Now this last one is a rational function, but don't get excited because you can't factor and cancel anything. So this one you're going to have to call on your knowledge of graphing rational functions. We spend a lot of time calling on our prior knowledge in this course. So this is going to be a hyperbola that is shifted right by 3. So it's this general shape here, and then another branch over here. So our core 1 over x function shifted right by 3. We have a vertical asymptote here at 3. Goes up to infinity coming from the right, down to -infinity coming from the left. So that limit does not exist, dne. So now we have some methods that are trickier and take a little bit more time and effort. So I'm going to go ahead and do this rationalization. It says rarely used, and quite honestly, not used much in AB Calc, but in BC Calc we will see it, so we do need to learn it. You're used to rationalizing a denominator. Like if you had 1 over the square root of 2, you would multiply by the square root of 2 over the square root of 2. In this case, our radical is in the numerator. So what we're going to do, oops, I meant to put a multiplication sign in there, hang on. What we're going to do is multiply by the conjugate of the expression in the numerator because this one includes the radical. So we have 1 plus 1 over x divided by itself. And I want to FOIL my numerator. So I have 1 times 1 is 1. My middle term, which is the negative radical times 1, and then 1 times the positive radical, those will cancel out. And then my last term will be a negative times a positive, so a negative. And then I have the square root of 1 plus x squared. And in my denominator, I am not going to FOIL it out or distribute. So when you do these rationalization techniques, what you want to make sure to do is FOIL out where you multiplied by the conjugate. And remember, the conjugate is just the opposite sign between the two terms in the expression. So I had a negative here, multiply by the positive here. So FOIL out where you multiply by the conjugate and leave the other one unsimplified. Now, I'm going to clean this up in the numerator by squaring the square root of 1 plus x. So I'm going to have 1 minus, and in parentheses, 1 plus x, all over the x times, in parentheses, 1 plus the square root of 1 plus x. And now in my numerator, do you see how 1 minus 1 will go to 0, and I'm left with just a negative times the x. So my numerator simplifies to negative x. The reason why I did not go ahead and simplify my denominator is because now my negative x and my x will cancel, and I'm left with a negative 1 over 1 plus the square root of 1 plus x. And I can finally use direct substitution and sub in the 0 to get negative 1 over 1 plus the square root of 1 plus 0, which is 1. And my answer is negative 1/2. So now what I'd like you to do is take a few minutes, hit pause, and go ahead and do your best to answer these questions, either using direct substitution, by using factoring and canceling, or by using something a little bit more creative, which is what you're going to have to do here for number 5. This might take you a few minutes to do, and that's okay. Hit pause and come back for your answers. Okay, great. Let's check your work. On the first one, I used direct substitution, and when I plugged in x equals 2, I got out 15. The second one, I also used direct substitution, and when I plugged in x equals 0, I got out 0. The third one I'm hoping you recognized from the very first page of this lesson. I factored my numerator, I canceled the factors, x minus 3, and then I used direct substitution. Notice this time I'm allowed to say that the limit is equal to 6. No longer is it approximately equal to 6, because when I use algebra, I get a definitive answer. Number 4, I'm betting most of you tried to use difference of squares in the numerator and denominator, and then you might have gotten stuck. But there's a nice trick on this one where if you just factor out a negative from your denominator, you'll end up with the factors of x squared minus 1 over x squared minus 1 that canceled, and you'll be left with 1 over negative 1, which is just negative 1, and my smiley face is for the nice trick. This next one you might recognize as being representative of the definition of the derivative at a point. You might have known that from pre-calc honors or AB calculus. So I actually tackle this one by foiling this expression to get 9 plus 6 times delta x plus delta x squared, and then minus 3 squared is minus 9. My 9's cancel, and then nicely I've got a delta x in each of my remaining 3 terms, and that leaves me with just a 6 plus delta x, and then I can take the limit as delta x goes to 0, and I get my answer of 6.